Okay, so this is another problem that we are going to solve today. One of the easier problem called as the gold mine problem, standard name, gold mine problem. The other one was called as the what do you call it? Subsets problem, coin change problem. Sorry, coin change problem.
And this one?
It's gold mine problem. That is called as coin change problem. Okay. Okay, let's read through the problem statement, guys. Given a gold mine of n cross m dimensions, there is a gold mine of n cross. This is basically you are given with a grid of n cross m. Each field in this mine contains an integer which is the amount of the gold in tons. Fair enough, right? You are given with a grid. Every entry in the grid represent the amount of the gold that is being present in that particular field, right? Initially, the miner is in the first column. Now we have a person who has to go and dig in the field. Initially, the miner is in the first column, but can be at any row. So he is somewhere first column, right? So anything. Okay, so he can be either any this. Let's say this entry is 8 1 3 9 4 6 5 4 3, some random data. Okay, so he can be anywhere. The miner, he can only move only right up and right down. Okay, so he can either move here, right up. Basically he can either move this place, sorry, he can either move either this place or this place or this place.
Right up or
Right up, right down, right right up, right down. If he's at here, if he is at here, then he obviously have only two options, right up and right, not of the right down. Okay,
right side में पड़ेगा.
right side में जाएगा. That is the objective. He can only go on the right side. Okay. The miner can move to the cell basically diagonally up towards the right or diagonally down the right or diagonal or towards the right. Okay. Find out the maximum amount of gold that he can collect. And obviously he'll stop when he'll reach the last column. Any row in the last column.
The right में नहीं जाएगा.
After that he cannot go right now. Right? So we have to find the maximum gold in the, for example, let me see. In this case, the answer should be 7, 15. 15 plus 9 is 24. 24 is one thing I got.
So in the first column, is it given that the place?
No.
Decide which is optimal.
Yes, you have to decide. Second part. That is what I'm saying. Initially, the miner is in the first column, but can be at any row. Okay. So 16 plus 8, 24, 35. I mean this path, I think. 35. Any other you can. I am not sure. Is there any other way? I think this is the one of the best gold he can get. Right. Problem statement is clear. There is a gold miner. He has to go and dig into the fields. We are given that, okay, if he dig this field, how much gold he'll get. He has to reach from first column till the last column. He can only move right up, right, and right down. And if you see, he will only make n steps, where n is the number of columns.
No, he can make only 3.
So 1, 2, 3, n minus 1. If n is the number of columns, then he can only make n minus 1 steps. Right? Any thought?
This looks like the first problem only.
First problem was rod cutting similar to rod cutting problem. Not exactly. Although the maximum keyword is there.
Max is easy.
Not 100% similar.
No, not 100% similar.
20% again.
Yeah.
So okay, what is the thought? Initially thought.
It will be a bottom-up approach.
It will be a bottom-up approach. How it will be bottom-up?
Because you have to sub-optimize from the last column. Because you have to. So when you reach the second column, you should have already optimized what is the best flow from the last one.
Right.
And then when you come first, you should have the optimized one.
Right.
So
okay.
that's
fair enough.
Bottom up. Second thing is, so at any stage, the max will have 3 condition checks. I of.
Got it. Fair enough.
Yeah. So that
okay. So
recursion. Recursion. Memoization bhi karna hai. I mean that's it. Memoization.
Okay. So I think I got your solution. I'll just refine it a bit. I think let me know if that is what you're trying to say. So where I should write gold, max gold of what is the ARR comma I comma J is equal to okay, 3 conditions.
Yeah, 3 conditions.
Okay, is equal to max of gold ARR I comma J plus 1 comma max gold ARR
So I plus 1 plus J plus 1.
I plus 1 and J plus 1, huh? This is for going down.
Going down.
ठीक है ना?
I minus 1, J plus 1.
No, that's it.
Right?
This and this. This and this.
Oh, okay, yeah. Oh, that way.
If I equal to, if basically J is equal to 0.
Yeah.
Right? Equal to max of gold of ARR of I minus 1 comma J minus 1 comma gold. This is still inside max, okay?
J minus 1. Although J plus 1 J minus 1.
This will be J minus 1.
J plus 1.
This is 4, this is 3. This entry is.
That is row. Column anything. Column will be always.
Okay, column J plus 1. Sorry. I minus 1, J plus 1. Sorry. Gold of ARR I comma J plus 1. ठीक है? If J equal to N minus 1 equal to max of gold ARR of, help me here, ARR of I comma J plus 1 comma gold I plus 1 J plus 1
and I minus 1 J plus 1
comma gold
I minus 1 J plus 1
I, just a second, I plus 1 J minus 1. No,
I minus 1 J plus 1. So I
from 6 I can go to this. This will be I minus 1.
So how come J minus plus 1? I minus 1 J plus 1.
Right. Yeah. Cool. Sounds like a plan.
And as part of recursion.
That's it. End of story. Okay, just look through the solution which Soumya has proposed. Okay. Okay. Last line will be clear. Just yes. Yeah. Is it clear?
पूरी रो के लिए चलेगी for every row it has to start.
Not yes. Max for j for I equal to 0 till n minus 1. Is it clear now? Clear? रवि नहीं क्लियर ठीक है नहीं ये सॉल्यूशन क्लियर हुआ जो है अभी
मैं कुछ और दिख रहा था तो
okay I'll enable it again. So first of all, for all, basically from this what can be the path, from this what can be the path, from this what can be the path, and from this there can some paths exist, and that's why I have written max of paths which can originate from 8, 6, 7 and 9. That's why max of paths for I equal to 0 to n minus 1. Is this clear?
this is row to n minus 1.
Yes, this is I is row, j is column.
Right.
Is it clear? Now let's decide what is the path. I am making the function max gold error of I comma j. I is the row, j is the column. Now if you are here, so in this complete thing there can be only three different kind of blocks. One is this block, another is this category block, and third category is this category block, isn't it? Because from here you can either go right and write down, from here you can either go right up and right, from these things you can either go right up, right down. So that's why these are in three different categories, and that's why these different categories. Okay, now from this categories what are the two options you have? This and this. You have to choose the maximum among them. So equal to max of gold of error of I comma j plus 1. I comma j plus 1 will be this, comma gold of I plus 1 comma j plus 1.
Right.
Right? No, this one. This is the one. If this is the one, if j equal to 0, then max of gold of error of I comma j plus 1, comma gold of error of I plus 1 and j plus 1.
Yes.
Right?
Right.
If n j equal to n minus 1, then max of gold of error of I minus 1 and j plus 1, I minus 1 and j plus 1, and gold of error of I and j plus 1. Clear? If third category, else max of gold of error of I comma j plus 1, comma gold of I plus 1 j comma 1. Yeah, this pass error, that is obvious. Okay, and this thing. Is it clear now? But effectively, we are definitely not going with n steps here. I mean, I'm not making n calls over here. Definitely. I'm making so many calls. I'm actually going through every possible path that I can go and finding the maximum among that, right? There will be path 8134, 8436, 8421, every possible path I'm going through and finding out the way, right? I have to find a better way than that. But it's really good. See how you are able to make out the solution, right? I mean, you can see the improvement, right?
told me that you need to start.
So that's why, that is what I'm saying. So that is the improvement we'll keep on doing. We were able to figure out by ourselves.
नहीं पर बात वाला तो पहले इंक्लूडेड ही होता है.
Sorry, बात वाला means?
पहले कुछ ऐसा नहीं था. ये 1 2 3 था.
1 2 3 is what?
This is a row. This is the mini
Array.
जो भी grid है. 1 2 3 और ये 9 8.
So why it is 10 9 8?
No, my example.
Okay. If we have 1 cross 2 as the one input,
Just really, but then let's say this example, I'm just trying to scale up. 1 2 3, there could be 3 paths, right? 1 2 3. One, it could be
1,
10 and 9.
Right.
Similarly, 2, there will be
10, 9, 8.
10 and again 3 path.
Right.
Similarly, this. But if you look at this 10, this is already here. So
Right.
we can use it.
Right. Definitely. Definitely. So that is what you are correct. So if you see this thing in this as well, 8-4. When I've gone through 8-4, when I've gone through 8-4, or let's say 7-4. When I've gone through this thing, now I have gone through this as well, this as well, this as well. This I have to go to this as well. Now, including 4 with 8, I have also already done that.
6, 7 तो सबके लिए
Right. Because for 4 is already been included. That is what I have to improve on. Ki when 4 comes, what is the best thing I should do? So I should have an answer whether if this entry comes,
So this is for one column. Let's say there are multiple
Columns.
balls are scaled. When you are at 4, you should know previously what was the best rate.
that is what I'm trying to say. When I include 4, which is the best path I should have gotten with the previous inputs, and now when addition of 4, what is the new impact on them, and which is the best among them that I should choose. That is what optimal substructure says as well. That is what the dynamic programming property says as well. The height example, if you remember yesterday, that I took people, right? So that is what we have. So that is also you are trying to say. So we have to minimize it. We have to stop our redundant calls that we will be making in this kind of tree structure. Start creating a 2D array. Create a 2D array. Start populating it. You will be pre-populating it with some of the obvious thing that you know from this the input, and we'll deal it further. But this is also a solution. I mean, this is a solution, valid solution. Okay. Okay. So now.
Hello.
यहाँ पे one dimensional array will be
For sure. Can you make out with one array?
I'm just thinking the only thing that we need in the array is any point of time. What is the optimal at that point of time?
And that will be from the row and column wise. It cannot be with respect to a column or a row.
Yeah, because that has to.
Another hint or another kind of start I would like to tell you is ask yourself a question that whether I should start. So one thing is clear to us that we will have to create a new 2D array. Are we clear with this part? This thing is clear to us. Now we have to pre-populate it, right? Now ask yourself whether I need to start from the first column or whether I should start from the last column. Why?
Because when you come to the first, you should be knowing which is the optimal. So when you're starting here, you should know which path I should take to reach, because your destination is here. So I should know that before starting here, I should know which path I should take to reach the maximum.
Okay.
You should start from first.
If you start from first, then what will happen?
So by the time you end, you know that what is the maximum you have already achieved.
In the last column?
Before last column, even if you try to reach to the last column, you might be come across a path which is maximum to this point. Maybe there is a duplication.
That cannot happen. That cannot happen. Before you still have some paths to process, they will definitely add to your previous solution.
Okay.
They will definitely add more.
There is something to.
Right. So ask yourself a question. I'm not sure. I didn't get your answers.
What I'm saying is, so before I start from any of the rows, I should know from where if I start, I'll get the optimal rest of the optimal. If I say there are n here, where can I start from here itself? So for me to determine this is the starting point, I should know the previous ones are optimal one.
Right.
Only then I can go ahead and go.
So how does it justify that you will start from back?
Something like Dikshatta is maybe you know the maximum weightage at the end. First you don't know.
Right.
But the end one you know that this is the weight I'm going to take. Previous one.
Right. So in a way, yes, you should right now in this question you should start from back. Why? Because which one to take from the start is not known yet. That is still a mystery to us. Right? But if we reach at the last, then definitely whatever is being there at that particular moment,
that will be optimal.
that is 4691 will be the same straight away copied. And if I populate it and go from the back, then whatever is the maximum in my first column will be my answer. Whatever is the maximum in my first column, because I came traversing from the back. So whatever is maximum in my first column,
add up whatever is maximum in the sum.
that will be your answer. Right? Yeah. So you will be knowing, okay, this is the place from which I should have started. So first,
in the last column there are two. There is the last column. There is the first row and the last row.
Sorry. Can you?
In the last column, there is a index at the 0th row index, and at the basically in the last column there is a one element at the 0th row and at the nth row.
Okay.
Now you may be
coming to the third column of the third row of the first column. From 0 or from 1. Yes, that's fine. But I came at the third row, na? That is decided. That is certain.
No, it depends upon what is the sum previously.
Right. That is what I'm saying. That it depends on the previous sum. It depends on the previous sum. I am not bothered about that. I am making certain that I reach to the third one because that is the maximum.
There could be two different paths to reach the first row and the last row. Let's say column is the last one. Now there could be two different paths.
To reach
the first column or the last column.
Okay.
The first index or last index. Index I'm talking about the row. Now it depends upon. Let's take an example. The path 1 total sum is 3.
Path 1 total sum is 3.
3. Previous total sum is 3. Now it is going to the first index. Let's say that value is 10. So there could be 3 plus 10, 30. Right. Now the last column, the last row's index, right? The value, let's say 7. But the path to this, that is part 2, that could be 20.
So you will come to 27 in that case. Then you should update the value 27.
27.
Right.
So you cannot, even if you start from the last one.
No, last. What you saying is last one, the value will never change.
I am saying don't start with this one. No. So whatever is your new array that you will create,
that will have the max value at that point.
These values are isn't it populated?
These are max values. Actually, what he's saying
This-
this represent the max value for that particular thing. So there are three paths. For all the three paths, you populate correspondingly, saying this is the max value if
For
I take one of them.
everybody.
Right.
Right. That way, at least for the last one, you know this is the max. It won't change. And when you come back slow from that, you know you're reaching the final.
Final.
That's what he said.
So try to do it with both the approaches. Start from the front or this thing, but your objective is to either reach start or either reach back for, last. Whichever is the maximum should be your output. So try to populate your array.
That would be, so it will be,
Sure. Okay, I'll read it out as well. Okay. Max gold pair of IJ.
like the logic, the table.
Okay, table this one, huh? Okay, so this is 4691. Okay, so this will be equal to
Max of all the plus brackets.
okay, either this or this. Okay, this then is your then you will be filling out this entry, which will be maximum of this entry, or this entry. So you pick 9 plus 3, 12. Then you picked out this thing. Then this will be maximum of this entry, or this entry, this entry. So this is 9, 11. This is 17. Right? I think it works.
So yeah, same thing. You go till here, so you know this is the highest. So you start. And this is the code.
Yeah. Simple, right?
Simple. Yeah, this actually helps you to create T2D and try to see how.
Don't write the code, Soumya. Just write filling up the error of new error basically. Okay. Just write a kind of a recursive function only. That's fine because that is almost the code. Just 3 conditions will do for you. Similarly, like this. Okay. Okay. So let's try to create a 2D array. Okay. Same of size n cross n only. 1, 2, 3, 4. 1, 2, 3.
कुछ ऐसा हो गया
33 आ गया आंसर.
नहीं उसमें मैंने कुछ और लिया
अच्छा. Okay. What is why 0 is there?
तो रो है
Okay. This is my array, right? That I need to check, right?
this one.
अच्छा. Sorry. ठीक. 98
This is 9987
99. So you started from here, is it?
yeah no, from the beginning
9.
9 दो के लिए भी 9
No, I didn't get the input here. Sorry. What is the input?
this one
This one is the input. Right? Okay. So
I'm taking it from this
what was pre-populated?
this one
No. So in this when
everything was 0
everything was 0. Okay.
I'm trying to the other way. See, if it is you start from here, I'll say 9. For this index, which one is greater? I mean, what are the path I have? So I'll put that 9 here. For this 3, I can go either of these. So maximum of this.
You have to decide from which part you are from. The
For
question
everybody, right? And then whatever the maximum I can take.
The first question is whether you are traversing from here to here or from here to here. Here to here. So either you will be here.
Starting from top.
So either you will be here. So I'll write it down. Let me. So initially you have done this thing, right? Right now. Then you came in order to fill this thing. In order to fill this thing, you can either come from here or here, and whichever is maximum, you choose that thing. So you picked 11 over here. Because 9 plus 2. 9 was already there. So I came from this part. So I did 9 plus 2. Is it what?
No. The first one itself I have taken, right? From, see, this is 9, right? 9.
This is right now minus 1. 0 or something.
Now taken from here also to go.
Yeah, from here, na.
So I think my logic is different. From here, I'll take 9. From 2, I'll take what is maximum of these two, I'm putting it here.
What will... Okay, what is the final answer? Tell me. 24?
24.
Okay, yes. Let me try to find an answer which is better than 24. Okay. हाँ 15 और 11 26 तो आ ही गया ये लो 15 और 11 26 ना वो तो आ ही गया तो ही मैं कह रहा हूँ कि तुम गलत कर रहे हो just see okay so I started from back I filled everything to whatever it was there 4691 and here this entry I can either come from this path or this path only two places whichever is maximum I'm choosing that simply so 6 is maximum so if I come here then I must have came from 6 and 3 is the goal which I'll get if I enter this path so 6 plus 3 9 similarly this is again I can come from this path or this path whichever is maximum I chose that 9 is the one which is maximum and 3 is the gold that I'll already get if I enter this thing. So 12 I placed here. Cool. From what places I can come to 9? This block. Either this path or either this path.
Yeah, 6 or 4.
6 or 4, right? Whichever is maximum, you choose that. 6 you choose.
Yeah.
So 6 already plus 3 if you land over here. So 6 plus 3, 9. Similarly for 11, you can either come from here, here or here. Right? Which is maximum?
9.
9. And if you land here, you will get 2 more.
Yeah.
11. And then 17, right? So simply here, similarly here, what will come? 11 or 17, 17 plus 7, 24 will come over here. Right? Then this thing, you have to choose between this and this. You can choose this thing. Right? 17 plus 1, 18. So what, 12 plus 4, 16. Then this thing, 12 and 9. So 13. Then 24 plus 9 is 33. And then maximum of 24, 18 and 16, whatever it is, 24 plus 7 is 31. And among them, whatever is maximum, 18 plus 6, 24. And maximum between 16 and 13, 16 plus 8, 24. So what is the answer? 33. Got it? Simple. Right? Itna time, Soumya?
Front se bhi utna hi hoga na. Start from front also you can use it.
I think so, yes. Let's try from front. So 8, 6, 7, 9. This will be 8 or 6 maximum 9. This will be maximum of 8, 6 and 7, 8 plus 4, 12. This will be maximum of 6, 7 and 9, 9 plus 1, 10. This will be maximum of 9 plus 7, 16. This will be, what was this? 12. 9, 12. This will be 12 plus 3, 15. This will be 12 plus 3, 15. This will be 17 plus 2, 19. 17 plus 8, 25. This will be 15 plus 4 is 19. This will be 19 plus 6, 25. This will be 25 plus 9 is 30. 25 plus 9. 9, 7, 16, 16 plus 8. This should be 24. So 33. And this should be 23 plus 1, 24. Right? Same thing, right? Clear? So just rather than gold, whatever new array that you are creating, replace gold, Control F, and do a utility instead of that utility array. And with this bracket, rest, this recursive function remains same. Right? No change in the recursive function. Right? Got it? Recursive function is now, rather than calling gold, we are calling from the utility array, and error of 5 dot j plus 1 is already being computed from the utility array, so I'll get that easily. Right? So this is what was one of the easier problem called as the Goldman problem, but the crux remains still the same, that we should know we have to create a 2D array and what is the significance of every entry in the 2D array. That is what we should know, and with that information we should populate that array.
Or without array can we do it?
How will you do that? If without array, then
Because
this function,
tree.
and that will also work, but that will be exponential complexity. That will be an exponential complexity.
You are not populating.
If you are not reusing the component that you have already calculated and keep on calling those components again and again, you are creating a necessity call redundant. That is not optimal solution. So DT basically converts exponential to polynomial. It basically converts the exponential time complexity to the polynomial time complexity, and n square is counted as one of the best solution in DP. Okay, so exponential will be raised to power n, polynomial will be raised to power some constant. Okay. So DP solution will convert exponential time complexity to a polynomial time complexity. Okay, is this fine? Okay, let's go further. Noted. Let's go one more problem. Is this noted? Noted. Guru? Okay. Let me see. Okay. Okay. And just tell you. Yeah. Okay. Let me. Okay. Okay. We are given with two strings str1 and str2. Okay, we are given with two strings. Okay, and you are allowed to make some operations. Okay, allowed to make operations on str1. Okay, like insert, delete, replace. Okay, insert, delete, and replace are the three kind of operation that you can make on str. Your task is to convert str1 to str2. We did the similar kind of question over there as well, where we constructed a graph. str1 to str2. Okay. For example, take an input. Take an input. But there, the constraint was, if you remember, the new word should also be from the dictionary. But here, new word we can be from anywhere. So this insert, I mean, over there we were having a better complexity because we were restricting ourselves to only those operations which are resulting in words which are present in the dictionary, and I was getting a hash map of the existing words, and from there I was able to figure it out. But here there can be n number of new words that can be generated. So that is where the scale of the problem goes. Okay. So str1 to str2. Let's say str1 is any string. Let's say A, B, ABC, A, B. Okay, str2 is, so basically you need to find the minimum number of operations. Okay, to convert str1 to str2. Okay. Okay. Yeah, A, B, C, A, B, and let's say A, C, C. Let's say this str. So minimum number of operation in this case, I think, will be 3. Three, na? Remove A, B, and C, B. 3 delete. And one more, 4, sorry.
You can delete
By 4.
Delete B, delete A,
Then insert C.
keep C, and replace C. So 3.
Keep C is also.
Replace B with C, na? That's fine.
3 only.
3 only.
my daughter there is no constraint, so
No, I mean, the C, B.
no, I got it. My only question is now it's here. I have different thing.
Okay, so in this case, we need 3 minimum number of operations so as to convert this thing. Right? Okay, this problem is called as edit distance problem. Edit distance problem. This problem is called as edit distance problem. Because what is the edit distance? That is what I need to find out, right? I need to edit str1 to formulate str2. And you can make 3 operations, insert, delete, and replace.
So, initial dots.
Huh.
If it is so, it can be the reduction or enhancement of the string that you want to destination. And then you can add string, add characters or remove characters.
Or replace.
Or replace. So if it is greater, if it is lesser, just first thing you should do is just chop out
Trim.
Okay. And after that, because this is you are reaching from A to B, it's reaching from so you should start from first, not from the end.
You should start from
First, not from the end.
Okay.
Unlike the previous. So you should then come back one by one and try to replace it with the correct or the destination.
Okay. Let's see if that works. I think no. Let's say string is A, B, C, C, B. And this thing will be A, B, C. So first you will knock off them, right? Comparing. Okay, let's say this is A, D. No, I'll take a minute.
अगर बीच में से डिलीट पे वो सारे सेम हो गए
वो फिर that will require lesser number of edits actually. That is what I'm trying to tell him. So A, B, B, C, C, let's say, and A, B, sorry, let's say the string is BC. Let's say the string is BCC. Let's say the string is BCC. First of all, you will chop two operations gone. Then convert A to B, one more operation gone. Then convert B to C, one more operation gone. Then convert B to C, one more operation gone. You took 6 operations. But effectively, it is pretty less. Just 2 operations, chop AB.
तो उसमें जो मैक्सिमम इक्विवेलेंट है
वो निकालना तो खुद में ही एक बहुत अलग से डायनामिक प्रोग्रामिंग की प्रॉब्लम है. Find the common substring between 2 strings. It is itself a dynamic programming problem. We'll discuss that problem as well. So don't go with that approach for now. You understand, Soumya? What?
Yeah. Simplify it.
So very basic idea. I mean, a thumb rule in every dynamic programming is first of all try to figure out what are the sub problems you're trying to solve. You should know what are the sub problems because every problem will have sub problems. Okay? So you should know what are the sub problems. Then you should know what when the least sub problem comes. I mean, very minimal size sub problem comes. Then how I'm gonna solve it? Then try to integrate sub problem, right? Then try to find it out. So first of all, identify what are the sub problems in it, and then see if you can find a solution to sub problems. Next hint. Anything? Any idea? Try to start doing it from the back. Yeah. Can you justify why I am saying start from back or start from front? Why not start from front?
So you can start from anywhere. What can
Back of what? STR1 or STR? That is also.
Okay, that is also a question. Okay, yeah.
you back from
When you come back, if it is necessarily we not to,
If it is, sorry, when you start from back.
yeah, if we are able to find that SR2 where is there, let me need not to search. For example, here, right?
BCC I found out.
Yeah. So if C is here only, where A, if C is here, A, C, A, C, we are able to find it in the further. Okay, A.
Then that thing can come at the front as well. If ABC is there, then I can need not go to the back. Right. That's
Yeah.
it. So see, the answer to that lies in the same thing. What are the subproblems over here? Okay. Tell me this thing here. If it had been only one letter strings, what could have been the case?
replace?
Replace in case what? In case they are not equal. Okay. The problem is what will come after it can impact this thing, isn't it? If AB is there, if AB is there and let's say BB is there, then if I start from here, then it is difficult for me that how many number of operations do I need to do, because after this thing something can come which can help me, let's say it was something like this.
What is the source and distance?
AB and BAB. If I start from front, then it is very difficult to identify whether, let's say, A or B I will do. I will either do replace, I will either do delete, I will either do insert, right? But actually, in a way, I actually have to make sure that I have to do delete, because in this thing, whatever is coming after B is helping me to solve my problem. The after part of the string is what making my subproblem decide what to do back, right? So I have to make sure that after this part, right hand side part of my strings is being solved every time. Is solved every time. Got it or not? Because see, it's like this. For example, let's say I give you A and A, right? You will say both are solved, right? Now if I say you B A, then what will you do? You are standing at here, you will say okay, it is already solved, but then you process here, then you should knock it off, because this part effect of B on already solved thing. Effect of B on already solved thing. That is what our purpose of this thing is there. Because the new thing which will come can change my whole structure. So start from back. Okay, start from back. Let's say my strings are this only: A, B, C,
BA and ACC.
A, B, C, A, B,
BA.
Take one thing, man.
AB.
AB, okay, and A, C, C. Okay. Now let's start from here. We will try to solve it from the back so that whenever new person come, he can disturb my string. But whatever I have right now, I will make sure it is correct. Okay. Now scan these two characters. What are the different operations that you can have? What is the two possibilities that can occur?
Replace.
No. What are the two possibilities it can occur?
Can match or
Same
cannot
and
match.
It can match or it cannot match. That is the only two. Match NM. Let me go to the next slide. This noted. Ravi, noted. Let me go to the next slide. Okay, STR1 was ABCAB and STR2 was ACC. So when we scan, the only two possibilities are there. This is my sure match and NM. If it is match, awesome, no? If it is match, I need not to do anything actually, right? That means to say, so far I am going good. I can easily trim off whatever comes, right? Now, but if it doesn't match, then I have to do something. So if match, then basically I minus minus and J minus minus. Where J is for STR2, I is for STR1, scanning indexes I'm saying. Okay? But if it doesn't match, then I have three possibilities further. Operations. I, D, R. I have three possibilities further. One is I, third thing is D, second thing is D, third thing is R. Replace. Right. Okay. Okay. Before that, M, comma, N. M is the size of the STR1, N is the size of the STR2. So far. Okay. And basically, if this is the case, then here the size will effectively become M minus 1 further to scan and N minus 1. So the problem over here will reduce to M minus 1 and M minus 1 and N minus 1. Is it right? If it matches. Clear, guys? In fact, I and J are always respecting to M and N. I and J are always M and N, and basically this M and N, and here that will come. Okay. Now let's do for this part, not match. I have to do three operations. Whichever is giving me the output, that is what I have to choose. That is what I have to choose. Basically, I have to consider all the possibilities, right? So let's try to do delete first, because this is what will be the problem now? What will the problem will become? If I do delete, what will the problem will become? If I do the delete operation.
Delete means operation is M minus 1. M minus 1.
Isn't it? You deleted, sorry, M minus 1 and N. Because you are transforming STR1 to STR2. My mistake. Is it clear or not?
Delete means M minus 1 will go. And then would be.
And N to rahega. Now you have to match the second last instance of STR1 with the last character of STR2. Right? Let's try to do it. What will happen over here? Okay? If you replace the last character of STR1 with the last character of STR2, that is what the replace operation is. What will it become? Awesome. Is it clear? Problem will become. What will this become?
M plus 1 N.
Will it become M plus 1? Can I go M plus 1?
M and M plus 1. No.
Can I go M plus 1? Because M plus 1 I cannot go, right? M plus 1 I cannot go.
Same. Invalid operation.
No, it's not an invalid operation.
What you want to insert? Nothing, right? If
That is
not
that.
matching, then don't insert it.
Think of from some other perspective. Think of with another perspective. I'll write it down, just validate. Okay. Does it make sense? Isn't it?
Match.
It doesn't match. In other words, now M, I have basically inserted B, and now I have to compare with up till here. It's like my STR1 was there. I have inserted the current character, and that's why I have got this operation, and that's why it is M. But N minus 1, which basically I am trying to create STR1 to STR2, right? I am trying to create STR1 with STR2. Right? So STR1 is now one character plus that means to say it is one character more than the previous character. That is why its length is m now. And previous character means to say the other str2 will be n minus 1. Okay. So think of it this way. This is the one ABCAB. Okay, and ACC is there. It can either be we matched these two guys B and C. It didn't match. It comes to this case. Now there are three possibilities. It is either ABC A plus B to AC, sorry, just a second, or ABCAB to ACC, or ABCAB to ACC.
First, second and third are same one.
Second and third. This is what is what. This is delete. Sorry. So m minus 1 will. This is gone. Yeah. ABCA to ACC.
In this third one, B and C and B will not be there.
Yeah. So effectively, you have added C over here in a way. Right. Now insert make sense? So basically, you did this effectively. You inserted C in ABCA in order to convert ACC.
Then trying out 5.
And now I'm trying to convert this part to this part because this you have already inserted. Does it make sense now? Now, what are the other options? I mean, think of that perspective. Does it make this thing? That if I did this thing, it says that you have inserted C in order to convert this thing to this thing. No, that is not true. I should insert C to convert ABCA to ACC from AC or something like that. Right? So my now matching string will be this only because last character I have already inserted it. Right? So that is why it is m minus this thing. M comma n minus 1. Right? Right? That's it. That solves the complete thing. That solves the complete thing.
After second iteration, you come to AC again.
Here?
No, sub problem. Now you go to the sub.
This part? It will be ABCAC with AC.
Correct. Now we know CC is matching.
So CC is matched.
We have to see A.
This now ABCA with A.
No, ABC with AC, right? CC has matched.
C is gone, right?
C.
No, ACC it was.
No.
The C,
Yeah,
but
C
then
one first one. Yeah.
Okay.
There's no first step also.
Okay, let's go again from the very start. Okay, let's see the call structure. Okay, so initially, guys, it was ABCAB comma ACC. Okay, what I did is I scanned these two guys. It didn't match. Okay, it didn't match. So I will come to here. Not match. So there are three options to me. One is insert. Insert means to say A, B, C, A,
C.
B. It will be B only because it is still. I added this character B.
We added C, right?
Insert.
That you don't know which character. So let it keep it that way. It will automatically resolve.
Why B?
See, you have inserted one character.
What?
You could have inserted B, A, C, X, Y, Z, so many characters. So you have inserted, so keep the string as it is. ABC, AB and AC basically. It will try to match with this thing.
Okay.
Okay, now let's go further. Then it will be A, B, C, A and ACC. And here it will be A, B, C, A and AC. Okay. Now let's go this thing. Not matched. Again come to the 3 portions. What will happen? You have inserted basically B while this thing. So it will be A, B, C, A with A. Okay. And here it will be deleted C, deleted B. A, B, C, A with AC. And here it will be A, B, C, A with A.
Last one is replace. So
Oh, sorry. It will be
A, B, C.
this is fine. Na?
Replace.
Okay. Okay. Is it fine?
Yeah, that's the problem. This is A.
This is insertion.
Then
So M comma.
You should have C also, right? We are replacing A with A, then it should be C, right?
No. This is what I have got. A, B, C, A, B and AC. And last letter didn't match. So it is still actually A, B, C, A, B. Sorry. It is still A, B, C, A, B. It is still A, B, C, A, B. This is A, B, C, A, AC. Right. This is A, B, C, A with A. Right. Now again, matched, not matched. Further 3 portions. One can be A, B, C, A, B and blank. This will be delete. So it will be A, B, C,
ABC.
A, B, C and AC.
Yes.
And third last one will be
AB.
A.
ABC.
No,
A,
third
B,
one will be A, B, C
A.
and blank.
ABCA and
Replace
blank.
with A only.
ABCA and blank.
This is what?
Replace.
Replace. So
No.
ABCA with blank.
Just a second. Is it up till here? It is clear. And we are A, B, C. Okay, sorry. A, B, C, A,
And blank.
A, B, C, A and blank. And blank. Right? Is it fine now? Right. So
I mean, the second part is
Yeah, second one.
down one.
down.
I'll repeat this one. First part for this thing will be insert, which means to say A, B, C, A, B blank. Second part will be delete, which will be blanking from the first string, which is A, B, C, A and A. A, B, C, A and A, yeah. And third part will be blanking from the both the strings, so A, B, C and blank.
No, second will be ABC and ABC and A.
Yeah, that is what I said. A, B, C,
And
A, B, C and AC. A, B, C and AC.
No, second is deletion, right?
Delete is M minus 1 and N.
You're deleting both.
No, deleting both will happen only in replace.
Right, sorry.
Right? Now this will be, in order to do that, it will further, let's say it returns me whatever the length of the first string is. Basically we are trying to convert this to this. Essentially this problem is meaning this. So the solution for that is 5. Right? It's a very basic subproblem. Converting, this is further a subproblem. Converting A, B, C, A, this will give me 4.
So the stopping condition is blank, basically.
When str2 is blank, then answer is str1 length. If str1 is blank, then answer is str2 dot length.
So convert to Y.
हाँ नहीं हुआ.
No, it's
नहीं हुआ. This is one of the solution. See, this is one of the solution. If you see what this path we took, let's try to take this path. What?
if it becomes blank, it means don't go further. Right?
No. Okay. Let's elaborate what happened this path basically. Okay. First, what we did is A, B, C, A, B. Basically, this was there. It didn't match. What we did is it was basically it was A, B, C, A, B again, and then it was A, B, C, A, B, C, A, B was again, and then it was what was that? A, B, C, A, B again. and then we said you remove all of them.
When there is a blank, there is nothing to replace.
Nothing to replace. Yes, yes. So if you see, you took 3 iterations of this. You took 3 iterations of this. You made the other string blank, and then basically whatever is there, that is the 5 combination that you took. So essentially, what I am trying to say is that you did this thing: C C A and A C C. So what basically you did is the path is A B C. We started with A B C A B. Okay. This will represent A B C A B C. Okay.
Yeah.
Further, this path will represent A B C A B C C. This path. This actually is this node. This. Further, this where it got blank, it is actually A B C A B C C A. Then further it got blank out. Then further this, and you got ACC. Okay, I'll do again. No problem. We'll first this is clear. I need to go to the next slide. Okay, ABC AB ACC. We'll try to go again. Let's only investigate insertion operation. Okay, ABC AB and ACC. Okay, what I'm trying to say is that you keep on inserting C further. Okay. First part, in the first iteration, when I say insert, I will only insert C.
M n minus 1, right?
Insert is M and N minus 1.
Yeah.
Okay. Forget about that thing for a bit. Let's go logically first. So it will be A, B, C, A, B, C, ideally, and what? A, C. And you should.
Actually, deletion.
No.
Man, you have inserted C here. You have inserted C over here. This becomes C, but now you should, this character you have already made them match. Now your point of concern is this and this.
Correct, but I'm saying this is actually an insertion operation. When you
Yes.
make a character match, it is not deletion, it's insertion.
This is, I'm only talking about insertion. I'm only talking about insertion right now. Is it clear? Now you should only match AC and ABC AB. Because last character you anyway inserted. Now further it will become what? Insertion you have to do. You will do A, B, C, A, B, C, C, and it will be A, C, C, but the pointer again will be here and here. Is it making sense now? Now what will be the further case? What will be the further case? A, B, C, A, B, A, C, C, A, C, C. And the pointer will be here and here. And that is what I was doing as well.
No, but if you think, I mean, I'm just thinking, how does it actually convert that string to this? Just
It is not that. That is what we are taking care with the M and N. I cannot write to this string. That is why I was taking M and N pointers. We are only comparing. I cannot add to this str1 ACC effectively because that's a final string. I cannot do that. That is why I am, decreasing my this thing and all that. My pointers. That is why I am decreasing my pointers, because when my this pointer will reach, it is just understanding for my purpose. When my this pointer will reach this portion, definitely if this goes null, then the answer to this I know what is the length of this string, which is 5. So if I have to convert this string into ACC, it will take 5 deletions and it will convert to ACC. So if you have to do insertions, then you will be taking 3 operations to this and then do 5 deletions. Isn't that the obvious thing? Nahi, Guru?
3 items. After 3?
After that, it is then if str2 equal to null. If basically this n, if n equal to -1 or 0, -1, then return m. If m equal to minus 1, return n.
Maybe string to convert in English.
यार string actually में convert नहीं करना है boss.
No,
String convert नहीं करना.
Even with the insertion, 5 operation of insertion, we cannot convert.
I can. I am not doing 5 operations of insertion. I am doing 3 insertions and 5 deletions. After that, I have to do 5 deletions.
Okay, the rest of go to A.
From A to B, you need to do this.
Yes. Okay. Because I know what is a in order to convert a something like that to this thing.
Yeah. Okay.
What will be the number of operations? 5. Any string, right? Or converting blank to a will take what? 3. Because those are my basic conditions. The answer to them I know. Right? So that is why I cannot, intuitively that is what we are trying to make out, but I cannot replace my str1 with abc ab acc. I cannot append characters at the end because that's a final string. That is why m is what m and n only I have to play with.
We are just trying to find number of operations.
Number of operations. We are not trying to replace the strings actually. I am not trying to do that. I am just trying to find the number of operations. That is the question. Is insertion clear now? Deletion is clear. Replace is clear. Can you write down algorithm for now? Actually, it's already been written, but frame it. Guru, is it clear?
Yeah.
Before we inserted 3, so deletion के लिए पहले totally 8 operation हुआ ना.
हाँ.
You say
If we go via insertion path,
5, right? Oh, for deletion only 5 years.
that is what 5. This part only plus 3. So if I had chosen my insertion path, then my answer would have been 8. So the objective is to find all the possibilities.
Do for all the operations and see which is the lowest.
Exactly.
Awesome.
The combination of all of it. You insert.
Yeah, the DP करता ही है. You find all the combinations, then find max or min between them. रवि क्लियर हुआ? पक्का ना? Just write a recursive function without array. No. That is a different story altogether. That's a different world. I am asking you to write a small function, recursive function, which will calculate all the possibilities and will then find a minimum among them. So with every DP, generally we will go with 2 kinds of solution. One is the finding all the possible outcomes and then find the best among them. So first write down a function for finding the minimum among all the possible solutions.
So the output will be number of steps, right?
Number of
Minimum.
minimum number of operations that you should do in order to convert STR1 to STR2. Now it's very easy to frame a recursive function here. हुआ रवि? अब तो हाथी निकल गया, पूछ लगे यार. It's 99% it is done.
We'll write it 2 years there.
That will be
भेज देना 3 भेज दिया.
the operator, you have used operator in a wrong way. Is it what the definition of minimum is? Minimum among what? Minimum points, minimum among two things, right? Where is the second thing over here?
ये तो प्लस हो गया.
हाँ तो ये प्लस क्या आ रहा है?
Then this will be the other one.
तो कॉमा और प्लस.
कम ये ऐसा जाएगा. ये इसमें से वो 2 मुझे लिखने पड़ेंगे.
हाँ तो ये तो लिखो ना. That should not be plus.
Yeah, there will be another function of
Okay, let's do
Mode 2.
Okay, sure.
Hello.
Just recursive function, Swami.
Just two. There'll be two max rates comparison. Max of
Min comparisons basically.
Yeah, min comparison. Yeah, min of deletion insertion. Out of that, what will come? Min of insertion and replacement.
Okay, so you could have written as okay, got it. Do. That's fine. Sorry. Because now looking, there's no. I'll tell you, there's a problem. Let me tell you. You are not finding anything. I mean, it will always return you 0. Always. You're not doing anything actually. Isn't it? Just run for small AB, BA, let's say. Run for small AB. One STR is AB, STR2 is BA or B or anything. Done somewhere? Okay, that's fine. Show me. But I have to just zoom. So to you also it will return always 0.
I know. That's a
So guys, one important thing, yeah, that is what I wanted you to, highlight by yourself. You didn't do that. Okay, I'll write down the function. Okay. Sure. Okay, rubbing this. Going to the next slide. Cool.
Just so you need to separately find the insert, delete, and replace. Then you will see the operation.
Then we have to see which one is giving me the minimum result. Yes. Which among that path is giving me the minimum result? That's
Or total in that how many replace or not like that, right? Replace, delete, and total operations.
total number of operations I'm concerned about. Not insertions are these many, replacements are these many, deletions are these many. Find the total max, total number of operations that you have done in order to convert STR1 to STR. What was the function?
String.
What is the problem? Find number of operations or not. Okay. Edit distance str1 str2 m comma n, okay, is equal to
ये ML पास करना जरूरी है STR1 और 2 को ही ट्रिम करके नहीं
I cannot do trimming on str1 and str2. They are final strings. Okay, equal to first base conditions equal to m if n is less than 0, equal to n if m is less than 0, and m greater than 0, greater than or equal to 0, and n greater than or equal to 0. Yeah, that is fine. This is not required. Okay. Equal to now what we have to do, this basically is for termination conditions. Okay, now two paths exist, right? Is equal to minimum of two paths, either matched or not matched. Okay, is equal to minimum of just a second. Sorry, equal to edit distance of str1 str2 m-1 comma n-1 if str1 of m equal to str2 of n. Clear? Do I need to make any operation when they are matched? Right?
No, you have to reduce
that is what I did.
Yeah.
Now equal to, here comes the main part. Equal to now I have to do something.
Just fourth equal to, or
Fourth equal to.
None of these conditions.
equal to minimum of edit distance of str1 str2 m comma n minus 1 comma edit distance of str1 str2 m minus 1 n comma edit distance str1 str2 m minus 1 n minus 1, this whole thing plus 1. This is where I'll get my count, because you have already done one operation. So you should increment your count by 1. You have either done make, replace, insert, delete, whatever you have done, but you have done something. So you should increment your count. And that is why you were not doing things, you were always at 0, whatever you do. If you don't add this thing, what is the value can you get any value without this thing? No. You will always get 0. Right? This is important. This is very important.
Yes.
Plus 1. That's it. End of story.
But it's the same.
But that, yeah, this is the main crux. Right? Is this clear?
Yeah.
Do you want me to write a code for this?
No.
It is actually code here.
Yeah, it's code only. Else condition.
Okay. So that's it. We'll stop here. Yeah, we'll stop here. Tomorrow, not tomorrow. Next class, we'll go with the better solution than this. First of all, we'll do a memoization to store this thing to help us design a better solution than that. Okay. After that, we'll cover some more problem on dynamic programming. In the next class, probably we'll try to end up dynamic programming in the next class. And in the final class, we'll take a new data structure, two new data structure, and there are any problems if you guys have any. We'll try to take suffix tree and we'll try to take binary index trees. Okay, those are the 2 important data structures which you need. I mean, they're advanced data structures. They are not okay.
Or a hash tree.
Hash tree is in Java, and that is what. It's the sorted one basically, sorted hash map. Hash tree is not as such any kind of data structure. I mean,
Do you think that